We started this just last year. This is the second time we're doing a new student orientation. So it's something that has always been kind of in our minds that it would be good to get you guys in here, get to know you, see your faces. One of the real downsides of the online program is that we don't get to see your faces very often. And we do try to run the program as asynchronously as possible. Asynchronous just meaning that you guys can access the material at any time. You don't need to get on at 5 p.m. on a Friday. A lot of programs do it that way, and there obviously are benefits to that, having that more of a face-to-face discussion. But it's really hard if you're working full-time and have 3 kids to be able to make that work. So that's why we run the program the way we do. And I suppose if you were more interested in a synchronous program, you'd probably do that one instead. So yes, I'm Garrett Strickhoff. Welcome to CSUF. We're glad you're here. Sorry, I had a pop quiz for you. I'm trying to make this light, of course. Who's our mascot here at CSUF?
Tuffy.
Tuffy Titan. How many students do you think we have at CSUF? I think this is graduate and
28? 34,000?
A little more. 40, yeah. 39 and change. But we have been over 40 in the past few years. CSUF and CSU Northridge swap places as the biggest of the CSUs most of the time. How long is this program for the typical student?
2 years.
2 years? Slightly less than 2 years. You know, it's 4 semesters in a summer. What's my name? It's one of those funny things. I come across students all the time. They're like, "Hi, Professor, how's it going?" I'm like, "You have no idea what my name is, do." But that's fine. There's a lot of different faculty here to meet, and especially for you guys being online, I would not expect you to remember all of our names all the time. Although actually, it's kind of different because you'll see us all the time as we record our faces for the videos. We just don't see you as often. Yeah, so I am the coordinator for the program. That does mean that I'm also your graduate advisor. So everybody has an advisor you can go to. The undergraduates have a different setup, but the graduate students have either Dr. Kim if you're an MSCE student, meaning Master's of Science in Civil Engineering, and Dr. Spardoff if you're a online environmental student. And so that means if you have questions about efficiency classes that you need to take, if you have questions about what course you want to take, very rarely, but every once in a while, I have a student who comes and says, you know, I have a hydrology background already. Maybe instead of 571, I could take a different class in informatics or something, you know, to actually expand your degree beyond just things you already know. And we're happy to work with you that way. The way it currently works is we have 10 classes to fulfill 30 units, and so everyone takes all the same classes. And that works out really well with the cohort model too, because you guys all live close enough that you're able to come in on a Thursday afternoon. But once, you know, a lot of our students live farther away. Maybe there's 4 or 5 students who live close together in the Bay Area. They're able to form a study group and actually travel through the whole program with that study group. And that's something I strongly encourage as well. So we're ranked pretty high. Best College Reviews ranked us 6th in the nation for online Master's in Environmental Engineering programs, which we're pretty proud of. We're ahead of a lot of good schools. We're ranked currently 26th in the nation for online graduate engineering programs by U.S. News and World Reports. And that one puts our 2 programs together. We have a Master's in Software Engineering that's also online. And so the MSc program and the Environmental Engineering program are both ranked together as 26th. And interestingly, that seems like not a great number until you realize we're actually the first among schools without PhD programs. So a PhD program, what that really means is they have a lot more money than we have. UC Irvine, I heard recently, if they get a grant, say they get a $100,000 grant, $58,000 of that goes straight to the university. So when they get a big grant like that, their indirect costs that they charge to the federal government is 58%. And I might be slightly off in the numbers, maybe 59, 57, something like that. But it's around that amount. For here at CSUF, it's 42%. So we're a little bit lower. But at the other hand, we don't bring in as much money because we don't have PhD programs. All of our research is done by master's students. And master's students are usually only here for a couple of years, so they're not as productive in bringing in grants. And that's just the reality of the situation. So PhD schools have a lot more money. They can put more money into advertising, more money into other various things that allow them to bring their rankings up a little bit higher. So we're actually really proud. We're just looking through the list of names. We're like, oh, we're 26. That's too bad. Look at the list. It's like, wait, these are all like Columbia is the number 1. UCLA and USC are tied for number 2. These are all really big schools with a lot of money. We're ranked 9th schools west of Mississippi. We're actually 3rd in California. So there's a ton of different schools in California, but we're actually ranked 3rd of online engineering programs. And 3rd in the nation for faculty. So these schools that have a lot of money, they're actually mostly hiring part-time. I'm just assuming, I'm shot in the dark here, but they're hiring a lot of part-timers to build these online programs. And the reason why they're building online programs is because the online programs bring in money too. Whereas in our case, we're going off of our faculty expertise and trying to train the masses. I believe the CSUs were always kind of designed as the schools to train the masses. We don't really focus on research as much, although we do some research, but really we want to bring people in who have diverse backgrounds and want to get a degree in engineering. And so we train you guys to be good environmental engineers by the time you're out of here. Ready? Someone, actually I was looking back at a student wrote back to me and said he took the PE exam, the professional engineering exam, and he said, basically what I realized is all 10 of the classes are just like little modules for passing the PE exam. So I think you'll be happy to when you come to take the test to see that. I'll show the slide right now just to kind of show you who's on our program. Jeff Gould is currently out of the country, so he's not able to be here today, but he teaches the an intro to environmental engineering class at 570. He also teaches air pollution, which is 583. And then 581 and 582 are soil and groundwater remediation and wastewater treatment. So his specialty, Jeff is crazy good. He's really smart, really good. He's got 3 PEs. You have PE in chemical engineering, mechanical engineering, and civil engineering or environmental. So he's just a really good guy. Sudarshan will probably be here later, Dr. Kerwiker. He's downstairs right now, but he teaches 546, which is your surface water pollution class. And then he also teaches 581 and 582, which are the soil and groundwater remediation classes and wastewater treatment classes. Fullerton is our current department chair. He teaches 571, which is the hydraulics hydrology module for the course. I'm Garrett, obviously. I teach water treatment, environmental law, and the graduate project class. And last but not least, Vinod Tiwari is currently probably not teaching in the program. He actually was brought up, he's just this past couple weeks ago was promoted to the Associate Vice President of Research Responsive Programs. So we're pretty excited for that he has that opportunity to move into administration. But it does mean we're not really sure who's going to teach the 515 class. 515 is our geotech class. It's a landfill design. We want to design landslides. Landfill design with no landslides. And it's a really interesting class. A lot of students like that one. Okay, so let's be honest here. Online learning is more difficult than face-to-face learning. Time management and self-motivation are very important. Yes, we can actually track how often you come to the website, but you can go to the website and fall asleep, right? So it's really important that you guys manage your time, that you stay on top of your assignments and your lectures. You know, generally we'll post lectures on Saturdays. I always try to give at least a week for assignments. So I usually post a lecture and an assignment on a Saturday. It'll be due like the following Monday morning. So I'll give you that whole weekend and the following weekend to work on it. But every professor is different how they do that. But you can imagine if you start falling behind, it's just like in any other class. Suddenly you find yourself in a hole and it's impossible to dig your way back out. Unfortunately, we have had a number of students who weren't able to pass through the program. They just got caught up with work. I hear this a lot where people are like, oh, I took on this new role at work and I just couldn't keep up. And I do actually encourage you in that case, come talk to me, but it might be worth your time, or it might be worth it to withdraw from classes that semester if you can still, just to protect your GPA. I'm going to talk about that later too. We give you as much homework, but less opportunity to form study groups. So you're not sitting in a classroom like this very often. And some of you guys are online right now, so you know what I'm talking about here. You're going to have a lot of homework. You know, we give you as much homework as you would expect in a regular class, but there's a reason for that. We'll talk about that in just a second. The cohort model does help. All of you guys will go through the classes all together, so all of you will be taking 570, 571 this semester. That means that if you come together, I mean, you're all welcome to do so today as well. If you come together and form a study group, you're actually going to go with that study group through all 10 classes. And I think that really does help out a lot. I see students, so you can tell they have a strong bond by the time of graduation because they've just gone through this program together. So why do you do online learning? Time flexibility, right? And you avoid traffic. I think, it took me a while to realize this, but a lot of people I think do online learning just to avoid having to come to campus after work through traffic. It might take an hour, and you're just sitting there in your car like frustrated. So instead, and a lot of my students do this, you're sitting in traffic listening to the lecture on your phone. So time flexibility is the thing. So why do you think we don't just make it easier? You gotta pass the PE too to make the big bucks. The other thing is, we as faculty have an obligation to you guys. So I put a picture of a ring there. It's the ring that I wear. Dr. Kerwiker actually has one too. It's based on the Order of the Engineer. I should say it is the Order of the Engineer, which is a ring. It's an organization that talks about the obligation that engineers have to the public. And I can show you some pictures, of course, about the obligation that we have. So this is a bridge in Minneapolis that collapsed. I was actually in Iowa at the time, grad school in Iowa. And so just north of where I was living in Iowa City, this bridge collapsed. And I had been across that bridge many, many times going in to visit friends in Minneapolis. Now the sad thing is, they found out that it was the engineers, and more specifically the contractors, that messed that bridge up. They designed it to have 5/8 inch thick gusset plates. When they built it, for some reason those either were not available or they just cheaped out. They built it with 1/2 inch gusset plates. That's only a small difference, right? Just an eighth of an inch from here to there. But it's enough that when they were actually doing bridge rehab, they were storing a lot of materials from the bridge, a lot of stockpile and gravel and that sort of stuff. And that load, plus and also the live load of a heavy traffic day, caused the whole bridge to collapse and killed a number of people. The bridge stood for 50 years, but then failed catastrophically. That's not something we have to worry about too much here as environmental engineers. Getting closer though, looking at earthen dams. This is a dam on the Teton, it's called the Teton Dam on Teton River, I think, in Idaho. It actually failed as it's being filled for the first time. It didn't even make it through a year or even a week. It's failed. They were starting to fill it up. They started noticing some leaks coming through, and within by that day, the whole thing fell down. 11 people died. 13,000 cattle were killed. Big problem. It cost them $100 million to build the dam and $200 million to settle all the things, like I said. This one hits more close to home though. Cryptosporidosis. If you do not have proper filtration of your water in the water treatment plants, cryptosporidium, you'll learn about this when we take 572 from me. Cryptosporidium is a very resilient organism. It forms a shell or a cyst that is very resistant to disinfection. But it's also huge. Compared to a normal bacterium, it's 100 times bigger. And so it's easy to filter out. You can filter it out with sand filters, no big deal. But if you don't monitor your sand filter, cryptosporidium gets through and a lot of people get sick and some people do die. Generally, it's something that if you've ever gone hiking and drink the water and then later experience some gastrointestinal distress, probably it was either this or Giardia that caused that. Sometimes called hiker's diarrhea. But if you have so in this case, I don't know if you read this, but 400,000 people got sick, ended up in the hospital because of this short outbreak of cryptosporidosis. Several hundred, I think, several people died too, but generally people who had immune deficiencies of some kind. So I'm doing this to scare you guys, of course, naturally. I'm trying to tell you the program is hard. I'm trying to tell you it's important that we keep it hard for you. But on the other hand, we've been doing this since 2012. 2012 was when the program started. A lot of people have graduated, a lot of people have good jobs, a lot of people are having a good time out there. So it's hard, but it's totally doable. Who do you want to go to for help? This is a good time to actually start introducing some people. So Camille's in the back there. You've probably seen some emails from her, your friendly ASC. ASC stands for Administrative Support Coordinator. Jennifer was the ASC for the program. She's the ASC for the Civil Engineering Department. And so she has taken less of a role in this program now. She more does the scheduling, that sort of stuff. But she's something you can go to for help if you can't find Camille. And their phone numbers are there. By the way, if you don't know, that extension is, and then whatever your extension is. So if you just give you guys the extensions, that's the number you want. 657-278. Blah. I'm Gary Starkoff, and then in the back we got Fullerton Mishra is our department chair, and then Dr. Korotker is in the back as well.
One thing I want you to note is you're here in our program. The name of the program is Master of Science. I need to really respect that. So now what we are expecting you are going to be a Master of Science in Environment. It's not a bachelor degree, it's a Master of Science. So there is a level that you have to attain. And just for that reason, you will see our policies and regulations are designed for that. For example, if you're an undergraduate student, you can graduate with 2.0 GPA. But if you're a graduate, no, that's not acceptable. So university policy governs that. So you need to have a D or higher on average on every course that you take. So 3.0 GPA is the minimum requirement. But we really want to have some standards in your education that you're going through. So keep that in mind. And along that line, you also want to remember, since it is Master of Science, you are going to be master in these topics. It's your responsibility. So there is a difference in undergraduate degree and master's degree. Undergraduate degree is more, you're given information, you accept it, you learn it, that's okay, you move on. But when it comes to masters, it's a little bit different. What we expect you need to be involved on your own. There is information that faculty is going to provide in our courses, but you need to go beyond. You need to become master in those topics on your own, right? So to become master, nobody can make you master. You have to become master on your own. So you need to indulge in those topics, go deeper as much as you can. These faculty we are all here to help you. We really want to see you succeed because you are who will define our future. The future of the program is you. So any help you need, anytime, you're always welcome to ask, and we're always here to help. But keep that in mind. The requirements that we have is high. It's not because just we want to make it high. Since it is a Master of Science, it's a higher level degree. It has to be B or higher. You need to get at least a B standard in the degree, right? So that's why everything that you're going to hear today, when Dr. Starkoff goes into the details of the requirements that we have, they're all around that you are getting a Master of Science in Environmental. Online programs are challenging because it's a different system. Online environment, although it sounds easy, you are in an online environment. But the way our human bodies are designed, we are designed to work in a group. When you're sitting in the class, although you're not talking to the person next to you, but you have that companionship. There are other people who are following. If you're lagging behind, if you see somebody, if everybody in the room understands, you don't, then your body starts to act differently, right? So you will start feeling that. You will say, well, why I'm not doing that well? You need to probably do something. But when you're in online mode, it's only you, nobody else. If you don't understand, you are going to give it up easily. So again, keep that in mind. So learning environment is completely different when you are in the online mode. This program is very successful over the years. I have seen a student transform. I have seen a student in my class, the one that you all are taking, coming from completely different background. I think the background of that student was finance, and the person ended up getting A+ in the course. A+, not just A+. Again, A+ grade is just an award, it's not a grade. A is the only grade that you get. A+ you get when you do something exceptionally well. It doesn't affect your GPA, it's just an honor. We are saying you did so well in this course. We are awarding you something extra plus. It doesn't affect your GPA. If you get A, you get 4.0. But A+ is something beyond. So again, but it all depends upon how much effort you put. And also I have seen a student who stay in the program for a few weeks, they say, well, that's it, I can't take it. So again, stay focused. There is nothing impossible. Anything that you see is designed for you to succeed in the program, and ask questions. And one story I'll tell you, last year I had a student, that person after 2 weeks came and said, no, I'm done, I can't take it. But that person came to that point, that person wanted to have a conversation, that was good enough. And that person did not give up. If you gave up on your own without having a discussion, you are going to give up. That's so easy. So if you are about to that point that you are going to give up, make sure you talk. Maybe there is something that you have in your head. It can be cleared by discussing with the faculty member. So keep that in mind. You will find this course challenging at point, but do not give up. Keep working. At the end, it will be a rewarding experience for you. It's a Master of Science in Environmental Engineering. Don't forget that. All right? Okay, thank you.
Well, hello, my name is Sudarshan Pawar, also called WK, and I'll be teaching stormwater pollution and control. And you will find most of the lecture material is math intensive, so it's a good idea to get a handle on a little bit of calculus, a little bit of math here and there. And I think one suggestion I would say is develop writing habits, because there is one project course, 597. It's writing intensive. It's different than your regular writing, you know. You have to paraphrase, synthesize the technical information and put it in a format that is presentable. It's more like a thesis, but not a thesis, it's a project report. Those are the only two things I would say. Last thing, when you watch the video, momentarily you feel that you have understood the material, okay, which is not true. Trust me, okay? So you have to actually physically sit down and do the problem on your own. When I watched the video, I'm telling my own experience. I watched a bunch of videos on Khan's Academy, a little bit of advanced topic, and momentarily it feels like, yes, I got it, I understood it. But when you try to redo it on your own, it's not there. You have to go back, rewind, and practice it. So don't get fooled by that momentary understanding that you have understood the material. Practice it and you'll be fine. We are all accessible, approachable. Anytime you have difficulty, reach out to us. Instead of reaching out to the wall adjacent to you, just send an email, call us, and write us. Because you cannot reach out to other students. So we have a blog to facilitate this community of students, you know, create a cohesive mass so that they can interact with each other, interact with their faculty. The blog is often monitored by the faculty member, but student can ask the question, hey, have you done question number 3? You know, how was it? I think there is a data missing. You know, that type of discussion is often you will notice in the student blog. So those are some of the tools that you can use. Other than that, I welcome you to Cal State Fullerton for our Master of Science online program in environmental engineering. My research is in the area of emerging contaminant of concern, pharmaceuticals and personal care products, insecticides, If you are interested in a little bit of biological type of research, like ELISA type of research, we recently acquired the enzyme-linked immunosorbent assay plate reader. We have some fancy photoreactor, we recently purchased it. So yes, opportunities for research are available provided you have time. Okay.
Yeah, and I would just echo what they were saying too. We are, I've been teaching this program since 2013, essentially my first semester of teaching. At that time, I was not particularly good at getting back to students' emails. So I didn't really conceive that it was so important. So now we're going to try to get back to you guys within 24 hours if you have a question, because I've come to realize that that's really the only mode of communication that we often have. And so if you send me an email and I haven't gotten back to you in 24 hours, just send me a reminder. I get like 50 to 60 emails a day that need to be responded to, and they sometimes do get lost, but they're also important. That's why I'm responding. All right, so the program timeline, you'll start out with 570 and 571 in semester 1. That's going to be your fate and transport of chemicals in the environment. And that'll be with Dr. Kuo. And then 571 is hydraulics and hydrology for environmental engineers, and that'll be Dr. Mishra back there. He's our water resources guy. In semester 2, we've got the 515 solid waste management course. As I mentioned, that's landfill design mostly. And then 573 is kind of an amalgamation of 3 different topics. So in 573, which is a course that I teach, we cover environmental engineering law, environmental law, I should say. We cover project management of engineering sites, and we also cover the last thing, economics. So we cover economics as well. So it's funny, as an undergrad and as a graduate student, I had full courses in each of those topics, and we kind of smash all the important stuff into one class. And it's it's kind of funny, that doesn't have the longest lectures because there's no math. So I just kind of lecture about the law, but they have to remember all the law lecture. Boy. In the summer session, you'll take 581 and 582, and that'll seem really cramped because you're taking 2 full classes in a 16-week period, I believe. So that's remediation of contaminated soil and groundwater, and then wastewater treatment and water reclamation as well. Semester 3, which will be next fall, so a year from now, you'll start taking water treatment, which is 572, and then you'll also take the graduate project. And we'll talk quite a bit more about the graduate project coming up here, particularly for the Midpoint students who are about to engage in that course. And then your last semester, you'll take surface water pollution with Dr. Kroeker, and 583, which is air pollution control with Dr. Kuo again. Now, a few students do actually take 4 classes per semester. Actually, in the past year, we didn't have anybody do it. We had one person who tried, he quickly dropped down to 2. But a few times we've had a few students who were not fully employed that were taking 4 classes a semester, and they indeed were able to finish in 1 year. So they took 4 classes the first semester, 4 classes the second semester, and then that summer session, and they were done. Now I have 4 criteria I think that you should have if you want to do this. So 4 of these 5, I recommend you be single, no kids, no job, no friends, and that you be very masochistic, not just a little bit. Because it is hard. A normal graduate student on campus takes 6 units per semester, and that's because a lot of times you have work or research that you're doing as well. Okay, so this is what Dr. Mishra was referring to. There are a number of policies in place. The university is not, I don't want to say as lenient, but they have different policies for graduate students versus undergraduates. So for example, one thing that you have to do in order to graduate is complete all of your deficiency courses. So if we talked about this before, you don't have to have them done yet. So the calculus, chemistry, and physics, those are things that you need to complete before you can graduate. And I recommend focusing on calculus and chemistry first, although physics you probably should too because it uses calculus. But the chemistry is really important, especially once you get to next fall when you're taking 572. There's a lot of chemistry in water treatment. You'll have a study plan that Camille will prepare for you. And again, from almost all of you guys, for 90% of you, that'll just be those 10 courses that everyone takes. But again, if you have a hydrology degree or an earth science degree and you think that maybe one of the classes is something that would just be a repeat, you're welcome to come. You would email me and ask for an exception. And for those of you listening online too, try to find a course that you would want to replace. So of the courses of those 10 courses that we offer, something you want to replace and what you would replace it with when you make a request like that. You do have to maintain your continuous enrollment in the program, and that's actually fairly easy to do via a course called Grad 700. And the nice thing about Grad 700 is that it's not as expensive as a full class. It does cost a few $100s. I think it's $300, $324, something like that. It's about $300 to maintain enrollment, but it keeps you on the books. so that you don't. So if, for instance, if you get a new job and you think to yourself, man, I'm really going to struggle this semester, that's a good time to enroll in Grad 700 instead. Take the semester off, get on pace with your new job. This is important to stay with your new job too, but we do not want to mess up your GPA. For a graduate student, there's no way to fix your GPA once it's broken. If that makes sense. And I'll get into that in just a second. So your GPA has to stay at least 3.0. If it goes below 3.0, they'll put you in academic probation. At that point, you've got 2 semesters to bring it above 3.0, at which point you're disqualified. There are some leniences. You cannot, I shouldn't say leniences. You cannot graduate if your GPA is below 3.0. If it's 2.99, they will not allow you to graduate at the university level. But you can take classes. You can take a class and try to bring your average GPA up. You're allowed to repeat up to 6 units, I believe. So again, try not to get below that. And it's surprisingly easy to get below 3.0 because if you get a B minus, if you have all B's and then you get a B minus, bam, you're below 3.0. So every B minus you have to get a B plus to average that out. Or if you get a C, you have to get an A plus or an A to average that out. So you always want to keep your GPA, keep it above a 3.0. Yeah, so you're able to take up to 6 units. So it's just 2 classes if you need to improve your GPA. Now at the undergraduate level at CSUF, we do have grade forgiveness, where if you retake a class, you can essentially erase the old grade from your transcript and replace it with the new grade. At the graduate level, they do not have that. So that's something that you're used to from an undergraduate. We do not have that at the graduate level. So if you get a C minus in a class, first of all, you have to have a C or better in every one of your classes. I didn't put that on here, but that's important too. C or better in every class, C minus does not count. So if C minus is essentially a failing grade in the program. If you get a C minus in a class, that means you have to retake it, but even if you get an A, the average grade is going to be below a B at that point. So you really want to make sure you don't fall behind. And that's why I say, I'm going to just put here, if you encounter a life issue, if you have a new baby, maybe your baby comes early and the baby's in the NICU for 6 months, that would be a really good time to think about withdrawing from classes for that semester. Because if you withdraw from the class, assuming you're before that the withdrawal deadline, it just shows a W on your transcript, no big deal. If you go through the end and don't do well and get an F, that's there forever, and it is really hard to come back from getting an F on your GPA. It's such a hit. So that's just something I want to say. Again, an online program can be more difficult. I don't think it's actually that much harder than regular grad school, but you have to stay on top of the lectures. As long as you stay on top of the lectures and do the assignments, you'll be totally fine. It's just very easy not to do that. So you have a study plan that you'll be making, that I'll be making, and Camille will be making for you. It's an agreement between me, as a graduate advisor. It's between you and between the Office of Graduate Studies. Ultimately, they hold on to that study plan. It's those 10 classes, and it says as long as you get a C or better in all these classes and your GPA is 3.0 or above, you're going to graduate. That's essentially what the study plan says. So it's 30 units of coursework. Every course on the study plan needs to be passed with a C or better, and usually it's before you've completed 13 units of study plan coursework. Now, one final caveat, if you have deficiency courses, we generally will not complete your study plan until those are off the books. So once you complete your deficiency classes, and if I haven't talked to you about this already, I recommend you go to a community college. There's one called Coastline Community College that actually has a lot of online courses. So Coastline Community College is a good place to go to find the chemistry, calculus, and physics classes all online, and they have summer sessions as well. So that's a good place to go for to clear these out. But your local community college works great too, and you can build a relationship with them because if you are off campus, you'll be using your local community college likely as your test center too. They tend to have good prices. This is what a study plan looks like. You can see those are it's not quite updated, but these are the 10 classes they'll have, and we'll share this PowerPoint with you as well. Camille will send it out to you. And yeah, so you see we've got several different kinds of classes, core engineering, environmental engineering application classes, and then a capstone research class, which is that 597 course. So you might be wondering why you need to take these deficiency classes, and the reason why is essentially because there's kind of an assumption that if you're an engineer, if you have the title of engineer, that you know, first of all, a little bit about calculus, a little bit about chemistry, and kind of a lot about physics. Engineers, in some way, we control and manipulate the world in some ways, and physics is all about how the world works. And so we have to know a little bit about something about magnetism, a little bit something about optics, a lot about mechanics as an engineer. So you don't necessarily need physics right off the bat in this class, although it probably would be helpful in 571. But you do need to have it before you can graduate. And we require the calculus-based physics as well because, when you take physics, you'll see that, especially when we talk about equations of motion, and everything else with physics too, but equations of motion, you look at the differential of velocity is acceleration, the integral of, the other way around. Differential of acceleration is velocity, differential of velocity is position, And if you don't know how to do a differential, then how do you move between these things? It's not possible. And then also, we do have a requirement for fluid mechanics and environmental engineering, but those classes have a similar topic as the first two courses in the program. So if you get a B or a better in 570, 571, we waive those requirements. And that's important too, because those two classes generally are not available at your local community college, the fluid mechanics and environmental engineering. Yeah, so as Dr. Carwetzer mentioned, he likes to put a differential equation on his exams in 546. Fair warning for you guys that are midpoint right now. So you want to have your differential equations out of the way before you take that for sure. And there is a ton of chemistry, environmental engineering. So environmental engineering is basically all broken down into chemistry and microbiology, and some combination of those two. Now, every year we get a few people asking why students pay campus fees even though they're not on campus. And the reason why is because you have the same treatment as though you were an on-campus student. The university does not have any kind of distinction between on-campus and online students at the administrative level. And that's actually kind of good in a way. It means that there's nothing you don't get that other students get, except if you live too far away to come get them. So there's a rec center on campus that faculty have to pay a lot per month, I think like $80 a month to use a rec center. Students get it for free. There's a student union that you can like get rooms and there's other stuff there. You get that for free. Subsidized childcare, membership in student organizations. And by the way, if you have children, the camp daycare on campus is very good, and students get a much better rate than faculty. Don't ask me how I know. Online fees is $33 per semester hour, and that's used for a lot of different things. So it comes out to be about $100 per class for each of the classes. It's used to enhance your online education experience only. We do not use it for anything else. So for example, it funds Camille's position back there, actually a quarter of her position. It funds faculty training and online teaching. It funds an orientation, this we're doing right now, lunch during exams. The exams can be a little bit of a long day because you've got a 2-hour exam in the morning and a 2-hour exam in the afternoon. We generally have some pizza and a little wind down time in between those two. We do on-campus exams. They're held, that might not be 100% accurate, but they're held in the morning to the afternoon on 2 Saturdays each semester. If you're not available on the Saturday, you're welcome to take them off campus as well. And you have up until the following Tuesday or Wednesday to take those classes, take the exams off campus. And like I said, there's usually pizza lunch available too. You can take it off campus at an approved testing center, and there is a link for the NCTA approved testing centers there. So if you go to that link, you can find a center near where you live. And there might be some that aren't approved, and if you talk to Camille, she can help you make sure that those are approved. Basically, they need to be proctored. There are some testing centers, surprise, surprise, that actually don't proctor the students. Students just go in there, they hand them a paper, and they go off like in a cubby and take the exam. If we wanted that, we would just do online exams. The reason we do the paper exams is we really want, it's actually twofold. I'm having a conversation with a student right now about why we do the exams the way we do. And one of the big reasons is cheating, to be perfectly frank. We've had instances of cheating in the past, and those students obviously got an F in the class. But that's something that's very easily avoidable if you just watch the student. So we do that in the classroom setting on that Saturday, but then also have the option to go to a proctored testing center as well. The other thing is the type of questions that we ask. In my opinion, at least, there is no way to write good, there's no way that I know of at least, to write a good engineering question in an online environment. Because online questions are generally related to either multiple choice, true, false, fill in the blank, that kind of maybe matching questions, that kind of question. But the kind of questions that we ask are more like, if you have this plant, this wastewater treatment plant, derive write out the formulas and tell me exactly what the concentration of VOD coming out should be. But not just concentration, I actually want to look at your entire process. Because frankly, 90% of you guys are going to get it wrong. The answer will actually be incorrect 90% of the time, and yet almost all of you will get almost all the credit. Because generally, when you have a 15-step process, there's 1 or 2 steps that get missed, but the other ones are fine. And so what we're all really adamant about partial credit, that we actually go through it and make sure that if your process is correct, but you just made a little flummox, like you put a negative sign where it shouldn't have been, you're not going to get an F on that problem. But in an online environment, online testing, it's either correct or it's not correct. And that's 100% points, 0% points. So I don't like the idea of an online test in this kind of a program, and that's mostly for your guys' benefit. The exams will be October 19th and December 14th. In the morning, here you can see the actual times. It'll be 10 to 11:50 for the 571 and 572 this coming semester, and then in the afternoon, it will be 1 to 2:50 for 570 and 597. And if you find that you're in 571 and 572 for some reason, let us know early, because it would be very difficult to take both of those exams at the exact same time. Okay, are there any questions so far for those of you that are here?
How do we find out if we have deficiencies that we need to take care of?
They would be on the GDR form that you might likely have received. If you haven't received it yet, Camille, I think we'll be sending it to you.
Yeah, so
Where are you
the
going?
admissions office should have sent that to you, but if you didn't receive a graduate department recommendation form, just let me know and I'll send you a copy of it.
Yeah, so graduate department recommendation form. It'll have a little box at the bottom that says deficiencies. And if you have a conditional admit, it'll mostly be because of that. So some of you are admitted, and some of you are conditionally admitted based on if you have the deficiency courses out of the way already. Yes, sir.
Will they send you something even if you have no deficiencies?
You should have these the GDR anyway, yeah. And as chemical engineer, you would actually not have any deficiencies. Okay, any other questions? Oh, yes.
You've alluded to a preferential order of taking these deficiency courses. I guess, can you go into that a little bit more?
Yeah, so basically what I was saying is that in terms of, so the question was about the order of deficiency classes. In terms of the order that I think priority would come, chemistry and calculus would be first, and then physics afterwards. And the physics classes are calculus based, so you have to take calculus first anyway. So generally when you're an undergraduate freshman engineering student, you take calculus 1, and then the following semester you take calculus 2 and physics 1, and then the following semester you take physics 2. And so it'll be, you can do it that way. It kind of depends upon how much you want to overload yourself too, but chemistry early, we'll definitely have chemistry done by next fall in terms of the 572 class, and then calculus probably also want to have done by next fall.
And if you wanted to not take 3 courses per semester and sort of elongate your curriculum, is that sort of up to your discretion? Is that something that
No, that's up to you. Yeah. If you want to take fewer classes, the only policy that would impact that is that you have to have all your classes done in 5 years. So they start to expire after 5 years. So, but that if you wanted to take 4 years to do it, that would be fine. Or if you wanted to maybe take 1 class per semester for the first year, and then that actually could have an advantage because you would take 1 class in the summer and then you take 1 more class next summer. The downside would be the tuition. I think the tuition might be the same whether you take 1 class or 2. Unfortunately, because it's one of those, if it's 0 to 6 units, it's one price, if it's 6 and above, it's a different price.
And if you were to do that, would you just follow the same order of the 2-year curriculum, but didn't sort of stretch it out?
Yeah, we could talk about that too. So I would probably recommend starting at 570, going to probably 573. Yeah, because 573 would be the environmental law class, doesn't have calculus or chemistry. And then moving into 572, yeah, we can talk about that. Or anybody who else wants to email me and ask about elongating the program, absolutely. And people have done that in the past. You're not the first person to attempt that. It works out just fine. The only downside is you lose your cohort. They go off without you.
Do you want to add, starting next spring, we are going to have an admission this spring. So that is going to help you more because then we will have the offerings of courses are going to be more easily available. So for example, if you missed 1 class now, if you have a new cohort coming next semester, you will be able to join the 1 missing class with them. So you'll have more opportunities to take courses.
Right. So for those of you on the camera, if you couldn't hear, what he was saying is we're starting spring admission. And so actually all of the classes are going to be offered every semester, except for the summer classes. We'll be offered every spring and fall semester. So instead of just, currently we're offering for this semester, 570, 571, 572, and 597, it'll be those 4 plus the 4 that we have traditionally offered in the spring. And so absolutely, that's a good point. You could take 570 this semester, 571 next semester, 573, 515, and then essentially move through the exact same sequence of courses, just at a slower pace. And you would completely lose your cohort every time.
You're the senior.
Yeah, exactly. Great, thanks. Those are great questions, guys. Okay, so this is for you guys. We have we usually get a lot of questions about the graduate project. So for those of you that are new students, this is for you. But it's also a lot for the midpoint students, the students who are finished with 2-3 semesters of the class of the program and starting into 597 this semester. So the graduate project is, well, let's just go through the slides. It's a structured class designed to teach you how to write a 5,000 word technical report in the format of our field. And that is actually a slight change. As of yesterday, it was 10,000 words, and I decided that was too much. So it's now 5,000 word technical report. You need to locate, read, and cite 20 to 50 articles, which sounds like a lot, but again, this report, this 5,000 page report, is essentially the only assignment for the entire semester. So writing, that's roughly 20 pages. Writing 20 pages for an entire semester, that's not really that bad. And then again, finding 20 to 50 articles, that's essentially one or two per week. They have to locate and read. You're gonna boil all that down to a 15-minute oral defense on the last day of a class. There actually is no midterm for 597, but we actually take some of that time and bring it to the final. So you'll have a 3-hour window for the final exam, which will be the oral defense instead, 15-minute oral defense. I think it's interesting, many students have complained that that seems like too short, because again, in the past I had written a 10,000 word paper, 40-page paper, and to boil all that information down in 50 minutes seemed like a crazy person would suggest that. But in reality, actually, that's usually how much time we have at professional conferences. So if you go to a professional meeting, they give you 15 minutes plus maybe 5 minutes for setting up and answering questions to do all, talk about an entire research project that took you years to do. So it's actually a skill to boil a lot of information down into just the high points. In the past, and I say in the past because it might change, I'm still working on the curriculum for the semester, the syllabus for the semester, but it was 7 lectures and 5 assignments covering, and the 5 assignments were fairly short and designed to move you in the direction of your final paper. So identifying and avoiding plagiarism, something we've learned over the years, is that some students think that it's okay to copy and paste information as long as you put it in quotes. And we'll teach you that's not really okay. That's taking someone else's credit for taking credit for someone else's work. We're going to talk about the parts of a paper. So if you read any journal article, you'll start to notice that they usually start with an abstract, move into introduction, maybe some materials and methods, results and discussions, and then maybe a conclusion at the end. So there's different parts of a paper, and it's kind of standardized how those look. We'll write a sample research proposal. We'll learn about taking research articles, so finding bad science, conducting a literature review, creating a research plan, conducting research and data analysis presentation. And those of you who are very observant might notice that's 7 lectures and 7 bullet points, and sure enough, those lectures correspond to those bullet points. So the graduate project, there are a number of different types of topics. The topic is entirely up to you as long as it's in the field of environmental engineering. Past topics include manufacturing, global climate change is a big one, the Great Pacific Garbage Patch. If you don't know about it, you should Google it because it's crazy that this thing exists. Desalination is another one, water rights in California. Water rights kind of gets into environmental law, but if you look at water rights in California, they are very, very interesting, essentially based on Wild West sort of policies. A rarely used option is to actually contact an individual faculty member and do research with them. And that would take the place of 597. So instead of writing a 5,000-page paper and finding 20 to 50 articles and citing them, you would essentially just work directly with Dr. K or Dr. Kuo if he's doing research right now. And actually really any of the faculty in the department, as long as they're doing environmental engineering research, to come up with your own project, generally within the realm of the projects they're already working on, and actually work one-on-one and get some research experience. You can take both places over more than one semester. You could take one class, you could do 1 unit in the fall and 2 units in the spring, or you could even talk about maybe doing 6 units. It does still require a written report, but it's not as intense as I guess it would be about 20 pages. So maybe a 20-page report. And then it does not necessarily demand that you live locally, although that would help and it would diversify the types of projects you can do. But I had a student who was in the online program that did research at the Arboretum here actually on campus, and she lived in Lancaster. So it was like a 2.5-hour commute for her to come down here. But we made it work. She just came down usually once a week or on the weekends when the commute wasn't as bad. Now, we have an online learning environment, which we call Titanium. Titan, of course, being the CSU of Titans. So Titanium is the name of our campus learning management software. You can find it via your portal. It's based on Moodle, so if you have problems with it, Google, how do I do this in Moodle? And that'll tell you you'll be able to find actually a lot of support online. Similar to Blackboard, if you used that in the past. Get to it through your campus portal, which is my.fullerton.edu. And at least for the faculty, it's just right there on the top. You can click on Titanium. For us, it's actually very flexible. It's one of those tools that has almost too many options. So you kind of get lost in the settings sometimes, but we can post lecture videos, assignments, resources, quizzes. We'll post your grades on there before you can see them online. There's a blog option. Dr. Misha actually does a blog off Titanium, I believe. That's even more useful, but different kinds of ways of interacting with you guys. And you'll upload your assignments into Titanium, where they will be graded by either us or a grader. And then again, the other is a discussion board. Already. So Titanium is going to be your best friend for the next couple years, and this is what it looks like. So this is my environmental law class, UGC 573. You can see we've got announcements at the top, which I don't use. We've got the course syllabus right there. It says read this. That's going to be the first thing. And then just to make things more fun, I put a little scavenger hunt in there, a little quiz that you get a grade on for reading the course syllabus. But spoiler alert, you can have the course syllabus open in front of you while you're doing it. So it's mostly just make sure you actually read the syllabus. Some information about how to access the proxy of the library if you're off campus. to find articles. And then each of the weeks, I like separated different weeks into different modules and go through that. And then a lot of things on the right, you've got student IT help desk. We do a 24-hour support on the IT help desk if you're on campus. Different other things, preparedness for emergencies, that sort of stuff. And the blog on the right there too. So that's all kind of compressed into one thing, and you'll find that most of the courses, these are similar. So what's on the right and what's on the left will be the same for all the different classes. And so it should, the navigation should be somewhat self-explanatory once you work through it the first time. All right, let's do this. In less than 2 years, you're gonna walk out of here, and as we emphasized, with a Master's of Science in Environmental Engineering. So you get a Master. I mean, you're gonna have 2 semesters of chemistry under your belt, 2 semesters of physics, and a whole lot of environmental engineering coursework under your belt. Look forward to shaking your hands at graduation, May 2021. It's not too far from now. Everyone we talk to at graduation, they say, wow, I can't believe this is over already. It seems like we just started. So it seems like a long time in the future for you guys now, but those 2 years go by really fast. Here we are on campus at the engineering quad here on our big, beautiful CSUF campus.